kid is collecting state quarters and new $1 coins. Now that sounds like a mixture problem, and I'm going to start trying to do a mixture problem, but find out it's just not going to work together. I know I don't put money in bowls. I do know I have quarters, which are worth 25 cents, and we have a price of $1 is $1. Prices in percents go on the top. We know there's 25 coins, so that's the total number of coins over here. But we're missing kind of something else. There's 9 more quarters than dollars. So if this is D dollars, I've got D plus 9 right there. I don't quite have enough information because I don't know what all this stuff is equal to value-wise. When the problem doesn't have everything, we need to try a different approach. Now this one's going to be quite easy, as you're going to soon find out. We've got 25 coins. The number of dollars plus the number of quarters adds up to 25 coins. The other clue is the number of quarters is 9 more than the number of dollars. We can almost just write that one directly using D's and Q's. With that information and these two equations we have here, I've got a Q equals, I'm going to do substitution. I'm going to substitute that second equation into the Q on the first equation. So the first equation becomes D plus, and instead of Q I'm going to have 9 plus D there, equals 25. Okay, we have one equation with one variable. Combining like terms, we have 2D plus 9 is 25. Subtracting 9 on each side, we have 2D is equal to 16. Therefore, D is equal to $8. Substituting into maybe that equation there, Q equals 9 plus D. Number of quarters will be 9 more than the number of dollars, so 8 plus 9 is 17. And we're going to have 17 quarters. Phew. Okay. You're looking at the next problem and you're seeing distance, rate, time. Now, again, with distance, rate, time, you have a couple patterns to look at. Two cars start traveling towards each other from 600 miles apart. Ding, ding, ding. I see that I have a total distance of 600. I'm looking for either a total distance or a same distance in these problems. That's the way I've taught it to you so far. So the distance of one car, RT, distance equals rate times time, plus the distance of the other car, its rate times time, is going to be 600. There's my equation to start off with. We know that one car is going 10 miles an hour faster, so one car traveling at R, the other car is traveling at R plus 10. You know that they're going to meet in 4 hours. Nobody gets a head start, so both of the times are going to be 4. The plus sign between there, and there's our equation. No tricks up the sleeve. We're done, almost. Now we just need to do some distribution with the 4 in that second parentheses. It's a little bit weird doing our distribution from the right to the left, but no problem. We've got 4R plus 4R plus 40 equals 600. Combining the 4 R's together, we have 8R plus 40 is equal to 600. Subtract off the 40, that gives us 560. And dividing by 8 gives us 70. The units are miles per hour, so that's one of our cars. And the other car we said was traveling at R plus 10. So the other car's speed is 80 miles per hour. That's not that hard, is it?